Hello, and welcome everyone to our Digital Electronic System project. This project was made by Abdullah Muhammad Abdullah Bahakim, Ahmed Nidal El Fitiani, and Hamoud Ahmed. So, first things first, we'll talk about the problem description. This section describes the motivation behind the project, which is a notable fire incident on August 20, 2023, affected six buildings in a furniture factory in Sungai Buloh. Fire-related statistics: approximately 6,000 premises are destroyed by fire annually in Malaysia. Issues identified: the lack of preparation or awareness, slow response to fire emergencies, absence of systems to handle fires autonomously when no one is present. Proposed solution: an automated system to handle fire emergencies using digital inputs and outputs. Then, let's move on. The system description: we have the inputs, which are the A, which is the smoke detector, B, which is the heat sensor, C, which is the gas sensor, X, which is the alarm, and Y, which sprays water, and Z, which calls the fire station. So, for example, if the smoke detector is not triggered, the heat sensor is not triggered, the gas sensor is not triggered, then the alarm won't sound, it will not spray water, and it will not call the fire station. Also, in another case, if the smoke detector is triggered, the heat sensor is triggered, the gas sensor is triggered, the alarm will sound, it will spray water, and it will call the fire station. Then, let's move on. System logic, or kind of maps. The system operates based on logical conditions. If A is high, all outputs X, Y, and Z are triggered. If B is high, X and Y is triggered. If C is high, X and Z are triggered. The truth table lists all combinations of inputs of A, B, and C and corresponding outputs X, Y, and Z. Example: A equals to 0, B equals to 0, and C equals to 0 will give us X equals to 0, Y equals to 0, and Z equals to 0. A equals to 1, B equals to 0, and C equals to 1 will give us X equals to 1, Y equals to 1, and Z equals to 1. Then let's move on. The logic circuit design. Two circuit configurations are presented. The first one, which is the basic gates, which uses AND, OR, and NOT gates to achieve desired outputs. Waveforms confirm the correct operation of the circuit. The second type, which is the NAND-NAND configuration, which implements the same logic using only NAND gates. Waveforms show identical results to the basic gates design, confirming both configurations are equivalent. Then, let's move on. The circuit analysis, which two sections are analyzed in detail. The second section, which its inputs are A equals to 0, B equals to 0, and C equals to 1. Its outputs are X equals to 1, Y equals to 0, and Z equals to 1. This basically means that when gas is detected, it triggers the alarm and calls the fire station. And then here at the sixth section, the inputs are A equals to 1, B equals to 0, and C equals to 1. The outputs are X equals to 1, Y equals to 1, and Z equals to 1. And this shows that when smoke and gas are detected, it triggers all outputs. All outputs. Then let's move on. Let's move on towards the comparisons of configurations. Basic gates. Let's start with basic gates. The advantages of basic gates is that they're easier to design and understand, and they have simplified logic circuits. Their disadvantages are limited operating voltage and inconsistent time delays. Then the NAND-NAND configuration. The advantages for the NAND-NAND configuration: it's cost efficient and suitable for data storage, offers higher operating capacity, and its disadvantages are it consumes more power and has potential errors due to additional connections. In conclusion, more it's more cost effective. The NAND is more cost effective and provides better storage and operational capacity. And it's recommended for implementing the fire detection system, key diagrams and tables, the truth table, which shows all the possible inputs and outputs conditions, the Karnaugh maps, which simplify Boolean logic for optimization, circuit diagrams, which have visual representations of basic gate and NAND configuration, the waveforms, which demonstrate circuit outputs for different input scenarios. And this was our project. Thank you very much for listening to us, and we hope to see you later. Thank you.